Hi there, I'm Scott Keller, founder of SignalFire Telemetry, and today we're going to be talking about SignalFire's I/O products. I/O products we define as sort of modules and nodes that have multiple inputs and outputs associated with them. Some of our other products connect to one particular sensor, but these connect to multiple sensors and can provide inputs and outputs to those sensors that are in a specific location out in the field. The two products we're going to be looking at are the multi-I/O module, which is coupled with our Modbus stick, and multi-I/O module, we also call it the MIOM. And then the other ones are wireless I/O module, which looks like this. They kind of look the same, but they're a little bit different. We'll talk about that in a little bit. But let's take a look at these and how they operate within the SignalFire system. So first we're going to talk about the wireless I/O module. The wireless I/O module looks like this. We'll have a close-up in a second. But it has 4 analog inputs, 4 analog outputs, 2 digital inputs, and 2 relay digital outputs. Okay, this unit here is SignalFire's wireless I/O module. And it has, like I said, 4 analog inputs, 4 analog outputs, 2 digital inputs, and 2 digital outputs. The digital outputs are relays. It's got an SMA connector here and a 300 milliwatt radio inside the module itself. So it's a fairly long-range radio system. And you can connect to the SMA connector here. You can connect an antenna on a panel mount antenna like this, or if your system is in a plastic enclosure, you can put a small whip antenna connected to that SMA connector right here. I'd like to show you the inside of the module here, which you can pry the cover off here with a small screwdriver. And inside you see the 300 milliwatt radio. And down here you see some slide switches. And those slide switches are so that you can set the inputs and outputs for 4 to 20 milliamps or 1 to 5 volts. And so you can mix and match whether you have a 4 to 20 milliamp sensor or a 1 to 5 volt sensor. The module is powered by external power, 6 to 36 volts. So it's good for 12 volt systems and it's good for 24 volt systems. Okay, so let's see how the wireless I/O modules work. We saw the inside of them and we saw them up close, but the wireless I/O modules can work in 2 different ways. Our standard node connects to a gateway, so you could put this out in the field with our standard Modbus gateway, and this would act just like a regular node, providing 4 analog inputs, 2 digital inputs, and 4 analog outputs and 2 digital outputs in the field, interfacing through the gateway. That's sort of the standard way it can work. Additional way it can work is you can take 2 of these nodes, no gateway, just a pair of these things, and you can set one up as the master and one up as the slave, and they just talk to each other. And you notice that there's 4 analog inputs and 4 analog outputs on each, and 2 digitals and 2 digitals, 2 digital ins, 2 digital outs. So what comes in on one comes out on the other. So the analog inputs that come in on one come out here, the ones that come in here come out there, analog and digital, both directions. So it's a great wire replacement tool. You've got analog signals you got to get from point A to B, or digital signals, or a mixture of both, especially if they're going in both directions. You can take a pair of these and just connect them up, and the long-range radios, they'll go a mile or 2 depending on the topography. So you set them up, and they're just perfect for wire replacement. Very easy to use as a pair like that. Again, so 2 operating modes, operating as a pair. What comes in on one comes out on the other, and vice versa. And then if you just have one talking to a gateway, so you have a gateway, you might have 1 or more of these out in the field with other kinds of nodes, and they're all talking to the gateway. So it's sort of the gateway-centric system where this is just an I/O node interfacing to the network through the gateway. Okay, we've talked about the wireless I/O module. Now let's talk about the MIOM, which stands for the multi-input output module. This is the module itself, and it's coupled with a Modbus stick. The module has no radio in it like the wireless I/O, and so the Modbus stick is used as its radio that's connected to the module itself. Modbus stick is a very long-range unit, so you can go several miles with this unit. The MIOM has a power input, 6 to 36 volts, so you can run it off a wide range of voltages. It's got 8 analog inputs that can be 1 to 5 volts or 4 to 20. We'll see that in a minute in the close-up. It's got 6 digital inputs and 4 digital outputs that are relay outputs. So let's take a close-up look at this thing now. Okay, so here's the multi-input output module, which we call the MIOM. It's got, again, power and interface are over here. Analog inputs are over here. Digital inputs are over here, and relay outputs are over here. There's 4 relay outputs, 8 analog inputs, and 6 digital inputs. Inside, you'll see that there's no radio, because again, it uses the Modbus stick for a radio. But inside, there's those slide switches. Again, you see them down here? And those slide switches are to allow you to set the inputs to 4 to 20 milliamps or 1 to 5 volts. And there's 8 of them, and you can mix and match them any way you want. Okay, so that's a close-up look at the MIOM module itself. And again, the MIOM is paired with the Modbus stick. You buy them as a pair, and it provides a lot of I/O in a single point. Now let's take a look at how we configure these things. We'll run our toolkit, and we'll connect up to these. We'll have some screenshots about how we connect to them and configure them. Okay, now that we've seen the MIOM and the wireless I/O stick in person, if you will, let's look at the configuration of them. I've connected up to the wireless I/O module with the SignalFire toolkit and the USB cable. I'm going to assume that you're fairly familiar with the SignalFire toolkit, which is this program right here. So I'm not going to go into that in too much detail. I'm going to select the COM port and auto-detect the device, and the wireless I/O module screen will come up. And it looks a lot like the other screens. You see up here in the upper left the COM port communication connection, how the thing is configured with the corporate ID here, 166, and the network in the group 1 and 2. The radio connectivity is disconnected because I don't have it a gateway running right now for it. Configuration is down here in the lower left, where you can set the corporate ID or use encryption. The other sort of standard setup things, the radio range and the slave ID. If you're running this in gateway mode, where you're connecting to a regular gateway, you need to set things like the slave ID and the node name you might want to set, and the check-in interval. If you're doing it in wireless I/O mode, just the radio network and group and corporate ID and check-in interval need to be set. There are communication failsafe timers that you can set up. This one's been set to fail output number 1 to 0 milliamps, and relay 1 is going to has been set to fail to a to its unenergized state. This one also has been set up to do some scaling on the analog inputs. You can scale them. So, for example, 4 to 20 milliamps equals 0 to 1,000, let's say, psi. And then all the data is up here in the upper right. So this is all the data that's checking in. I don't have any sensors connected to it, so you see a lot of zeros here. And you see the minus 250 or 249 here for the scaled value. Since I'm reading 0 and it's a 4 to 20, I'm actually sort of below the range, so that's why it's reading minus 249. Additionally, you can test the outputs, the analog outputs right here, and the digital outputs or the relay outputs right here. You can energize them and de-energize them for test right from this window. So there's a lot going on with the wireless I/O, and this is the setup screen. The only other thing I wanted to point out was up here, if there's firmware updates available on your computer that have been downloaded automatically by our toolkit, it'll tell you up here, and you can see I have 2 actually. And if I click on these, it'll actually bring up a window where I can do the firmware update. So that's the setup screen for the wireless I/O module. Let's now take a look at the screen for the MIOM. Okay, now that we've seen how to configure the wireless I/O module, let's configure a MIOM module and stick system. So I'm going to connect up, cable up the system, and do the auto detect. And it's going to bring up this window here, which, if you notice, it says Modbus stick. This Modbus stick is actually in the wrong operating mode, and what we need to do is we need to actually upgrade. We need to change to the multi-I/O stick firmware, because it actually runs different firmware when it's as part of this multi-I/O module and stick system. So I'm going to get this running right now, start that upgrade. It'll automatically do it. Your computer should have the firmware on its disk from when you actually sign in, and to the toolkit it downloads the firmware automatically. If it wasn't there, it would tell you. And now it's writing it. It takes a little while to update it, so let's just wait while it updates. Okay, now you can see that the firmware has been upgraded. It says the upgrade successful. So we'll close that window right there, and a new window is going to pop up that is the multi-I/O stick right up here window, and it's got a lot of stuff going on because there's a lot of I/O here. Down in the lower left here is where you set up everything. You set the radio range to probably long range. You set the network and the group and the check-in interval and the name and the slave ID, all that kind of information. Then there's a bunch of stuff that's specific to the multi-I/O module that in addition to all the I/O that it has, which is shown up in this area, you can scale the inputs. Here are your inputs, input 1 through input 8. You can actually scale them. So if you have 4 to 20 milliamps is 0 to 1,000 psi, you can do that scaling here. You can alarm on various channels. So you can say, you know, I want to check in immediately if the pressure goes above a certain level. So you can do alarming on both the analog inputs and the digital inputs. And then there's failsafe timers, which get set up in this area and down in this area, where if communications get lost, you can set things, relays and outputs to certain states. And that's really, you know, there's a lot of stuff going on, but that's, you know, I'm not going to go into all the details of the setup, but here's the regular kind of setup in this area, and then the MIOM specific setup in this area, and then all the I/O information is shown up here. If it was actually connected up to things, this is actually the data, but it's all zeros now because things aren't, you know, aren't connected up actually. You can actually, using these buttons here, you can energize and de-energize the relays, so in test mode you can see things working. So there's a lot of stuff going on here. It's a module with a lot of I/O. So anyway, that's the multi-I/O module system, and a lot of I/O for you to hook up to.